statistics can implement it in engineering. So for example, what is statistic is very common is lately because of the COVID, you use the test kit. So the test kit is saying that the accuracy is 99%. And the mask that you use, the filtration is 98%. So those value where you get it from. So it's actually get from the statistic analysis from the lab. So those are percentage to show you how accurate is that. Another example is you want to know the list, the current the current latest rate about COVID. So those are actually is the number, all the data number, and then you convert it into a chart for you so that you can be easily to understand. Another, yes, yeah, so those are the easy one. So what is statistic? Like I mentioned to you, mathematical methods to present and summarize data, analyze them and make a conclusion, decision and further prediction from the analysis. For example, I would like to buy a handphone. So you won't just randomly pick one and then just pay it, right? You might need to find some data collection. For example, oh, the latest brand is Apple, Samsung. They have the latest information, latest trend, technology. And another thing is reliability, how long they can sustain, how they can use. Will the handphone last? Or you just focus on the function of handphone, of the camera. So after you gather all the information, then you summarize in the data. It seems that Apple iPhone X showing the higher purchase now, for example. Well, why? So it's very expensive, and why so much people buying it? So then you further look at other issue, for example, the reliability, the smoothness of the using it, and so on. And you further analyze, you make a conclusion, and you decide which one to buy. And of course, like for example, the so for engineer, what about engineer? What can an engineer do with the knowledge of statistics? So for an example, our hard disk, our handphone, before we go to the market, all the gadget is actually sent to the lab, and they try to abuse them to keep on running them to see how reliable of the product. Yes, so we want to improve what is the factor that affect the product stability. So these things we need to look at the mean. We need to know a lot of analysis in statistics in a bunch of sample. We can't test each of them, but we can randomly using a efficient methods, statistic methods to choose sampling the sample to further test and represent the outcome. Okay, so for example, Western Digital is there is a company in Petaling Jaya. So they produce a lot of new hard disks every year for a laptop or for individual portable hard disks. So before they market the new product, actually there is a lab inside the factory that keep on testing the hard disk and see whether it's sustainable. So like in this slide is to identify the existing product. We want to know what is the important factor that affect the product. What part that we can further improve on that part. Okay. We also can control the variation of the problem. For example, we can play around with the range and try to see whether we can further improve and promote and make another new product from that. To build a model based on the collected data. Yes, sometimes it's very expensive. It's too expensive to make a real product to test. For example, a battery, the new electrode probably need just a little bit like this, a few volume, and it will cost you a few thousand. So it's to save the time and the money, so you can run few and you build a model from there. From there, you try to analyze and predict. Yeah, you can solve the problem based on the design model and design a new product model. Conclusion making and recommendation based on the problem solution. So by analyze all the data, we're able to propose a better way to improve the product, as I mentioned just now. So what can as statistic be applied in the field of engineering? So design of experiment. So to test and construct model of engineering component and system. So for example, I would like to come up with a new formula for a shampoo or a new formula for a lubricant, engine lubricant. So I can use design of experiment like Design Expert. This is a software. So by putting your important parameter in a certain range, they're able to, with a selected suitable design methods, you can come up in a shorter a list of the experiment, a shorter one, and not is still showing a good way to represent the to come up a formula. And quality improve by using that, you manage to conformance to specification of manufacturing process and their product. So by analyze the sample and further look at the figure, we're able to check the specification and we're able to further improve the quality. Okay, time and method engineering to set standard and find optimum manufacturing procedure. Yes, this is correct. For example, there's a compressor. So if you want to check the compressor from A to Z, that's very time consuming. But if you have a record on it and then you further analyze into a chart, it seems that the propeller, okay, the propeller or some part of the compressor, the part B, for example, inside the compressor, the piston is always make trouble. By looking at the data, we don't need to open everything and check one by one. By looking at the data itself, we're able to quickly analyze and focus on the problem itself. Product development and reliability engineering. Like I mentioned to you, so which one you prefer? A reliable refrigerator, a reliable product brand? Yeah, so for example, if I say Samsung is a very good brand, so how true is that? If there is a fact and a number factor to support it, it will be easily to convince the consumer. Okay, so statistic can be divided to two branches: descriptive and inferential. Inferential is something like, oh, you just randomly pick few person from the market, interview them, and that represent the whole consumer market in the market. Is that showing a detailed information on that? No, it's just generalize your outcome. Descriptive is you collect the data, organize, summarize, and present the data clearly. So this is what engineers should do. Okay, so and therefore, right, there are some important terms for this statistic: data, population, sample, unit, census, data set. Data is the measurement response that have been collected. For example, how much, how many students in the class, all the students, let's say 25 students, those are my data. Population is, for example, all the female students in the class. Sample, all the female students who wearing the glasses. So the unit is people in the class, right? So sensor is the collection data from every member of the population. So if you refer to the all the female in the 25 class, so the female are the census in this case. Data set is the collection of all observation of particular variable. Sampling is, for example, I have a population, you go to a cake shop, right? That is the population. What's the population in the cake shop? All the cakes, right? So target population, chocolate flavor. Okay, sample, the chocolate flavor with strawberry on top of it. So we are looking on that part. Okay, that's what you target on. So you can try on this part. A consumer magazine article asks how safe is the aeroplane in the air, and goes on to say that the air quality was measured on 158 different flights for US-based airline. Identify the population, sample, and the unit. So be careful. In this case, is the air quality is not, we are targeting now the airplane is our sample. The population is not the airlines, not all the airline in that in the world, but the US-based airline. The sample is 158 different flights. The unit is the flight, the aeroplane. Okay. So why sample? Why I need to sample? Why don't I just test one by one and ask one by one? Because this is very costly and very time consuming. We want to have the result as quick as possible, and it really fit and reflect to the real outcome. Okay, so yeah, that's why we need that. So may produce more accurate estimation, may sometimes impossible to conduct a census. So for example, you are going to produce 100,000 of a product. Can you test each of them? It's very time consuming and very costly. What you can do is you try to learn there are few methods that suit to your to further sampling your product. Okay, so this is the few criteria on sampling. Select the sampling. And by the way, types of data, there are two types of data. One is quantitative, another one is qualitative. Quantitative is something that measurable. For example, height, for example, temperature, something that measurable. Quality is like taste good, taste bad. You might think durian is smelly, but another one is good. So it's very subjective and different model. So those are quality. So you can have a look on this slide. I give some of the example on the qualitative and quantitative. This is the qualitative raw data. So and actually we can convert it into table form, right? So and next week I'm going to teach you again on how to convert a quantitative raw data into a table, into a much simple and presentable data. Okay, that's all for this class. I'll see you next week. Thank you.